Welcome to the Stray Pointers podcast, where seemingly ordinary people join us for extraordinary discussions. You're listening to Season 3, Episode 12 of the Stray Pointers podcast. This episode was recorded on December 1st, 2025. I'm your host, Jim Lawless. For more information about the show, including contact information and show notes for this episode, please visit straypointers.com. Joining the show tonight is longtime fourth programming icon and retired biker chaplain, Tom Zimmer. Tom, welcome to the show.
Well, thank you.
Tom, it's a pleasure. It's a pleasure seeing you face to face. You and I crossed paths about 25 years ago when I conducted an interview via email, and that interview that we had put together has circulated in various places for the past 25 years, including some fourth specialty magazines and that sort of thing. So I thought it would be good to maybe instead of doing a new interview on a webpage, to get you on the show, and let's talk about your history with fourth.
Okay, well, I hope I can remember enough to be useful.
Okay.
I turned 75 this year, so,
Great.
Memory's not what it used to be.
Great. Okay, so what was really your first exposure to tech?
Ooh, tech. Wow.
Yeah, electronics, that sort of thing.
Right. I don't need notes for that because that goes back to my teenage years when I was in high school. My father was an amateur electronic technician, let's call it that. That would have been back in the 60s or so, probably early 60s, late 50s. He he had a shed in the back, and with all kinds of electronic equipment in it that he had collected, and he would bring home televisions and repair them, and then I assume resell them or give them away. And because we always had electronics around, I developed an interest in it, and I remember my my first experience. This would have been before teenage years, trying to create a transformer by taking a piece of wire a few inches long and bending it over and plugging it into an outlet socket, which didn't go well, as you might imagine.
I bet you didn't do that twice.
No, I don't think I did it more than once. But anyway, that's how it developed. And then as a teenager, in high school, we had a teacher, Mr. Gamelin, if I remember right. And I had friends who were interested in the citizens band radio, 27 megahertz area.
Mm-hmm.
And we did a lot of experimentation with transmitters and things like that back then. That would have been in the late 60s.
Experiments as in linear amplifiers and that sort of thing?
Yeah, things like that. Let's see, I went into the military in like 70, I think. So when I was in the military, I happened to be stationed in the U.S. in the Air Force, and got quite involved with Citizens Band and built some linear amplifiers, illegal, of course, at the time.
Sure.
Mm-hmm. I don't do that anymore.
So that was your exposure to electronics. When did computers come into the scene for you?
Computers came in a little bit later when after I got out of the military. I still had the same friend. His name is Dick Capples. He was an electronic engineer, and let's see. Tell me the question one more time.
When did computers sort of make their way onto the scene? Yeah.
All right. So my friend Dick Capples bought me a personal computer And it was in the form of a bag of components, including a microprocessor chip. And he told me to go down to Wiley Elmar in, I think it was either Sunnyvale or Santa Clara, California,
Mhm.
and pick up my computer. And so I did that and hand wired it together into a small microprocessor computer based on the RCA Cosmac CDP 1801 microcontroller, which was a static processor, which was unusual at the time.
Mhm.
The significance of that is just that the static processors can run at a clock rate as low as 0. In other words, you can bring them to a halt and they don't die. Whereas dynamic processors like the 8080 or things like that were you couldn't run them below about 500 kilohertz. They had to run continuously or they would forget what they were doing. So I built that, and let's see, with it had a hex keypad on it and a I believe it was a 7-segment display, although it might have been a row of LEDs. I'm not sure.
Was this a Cosmac
And
Elf?
yes,
Okay.
well, it was in a sense it was a Cosmac Elf, but it wasn't a kit. It was not from RCA. It was just a collection of parts and a schematic for how to
Okay.
put it together, and I hand wired it. It was before wire wrap, and I mean it was hand solder basically.
Hmm.
Um, I was working, I think, at Pacific Telephone at the time as a not a lineman, as a central office equipment man. That was back when you could have man in the name of
Hmm.
the. Although we had women that did it. Anyway, the after that, I I got interested in computers in a more significant way, so I ended up purchasing an Ohio Scientific 500, I think it was called, that was based on the 6502,
Hmm.
and it had a disk drive and a keyboard and a CRT monitor, and it was a regular computer that ran their own Ohio Scientific operating system at the time, and it was inexpensive compared to most of the other computers that were more. I don't remember the exact cost. Um, and I ended up becoming interested in fourth. Not sure why. Let me think.
So in our previous conversation, you mentioned an 8085 fourth at a place called Calma.
Okay, I did get some notes on that, although I don't have them here. The Calma, when I was working at Calma, our purpose for working there was to test disk drives. I'm sorry, Maxtor built disk drives. Calma built graphic um, workstations.
Hmm.
They were a big graphic workstation company at the time,
Hmm.
and we built a fourth that was used for testing the these. They were enormous cards. They're like 14 by 16 inches, something like that,
Wow.
and they were emitter coupled logic, so they were really high speed logic, but because it was not TTL but ECL, they could run at very slow speeds. So we tested them using software at very low speeds, just for functionality,
Hmm.
just to make sure that the logic was working. It obviously didn't verify any timing related issues. And so the fourth that I guess I created it. it must have been, boy, the timing's getting, wait a minute. Yes, that would have been from a micro Fourth listing from Fourth Incorporated, I believe. And I think I hand typed it in, assembled it on probably an Intel MDS or something like that, and got it to work without much difficulty. But I didn't, and it had things in it like virtual memory capability and stuff like that, but I didn't know what that was. So I just didn't implement that
What
part.
can I ask how you knew about Fourth? Was there a presence in the magazines you were picking up, or did others contemporaries know about it? How did you find
You
out
know,
about Fourth?
that's a really good question, and I'm not sure I can answer it because I know I had a number, lots of friends in the Fourth community. Once I got started to get involved in Fourth, one of my first of them was, his name was Robert Riling, Bob Riling, and this would have been in the very early days of Fig Fourth, Fourth Interest Group Fourth,
Hmm.
and he went to the Mountain View Computer Club, or I think he was probably the president or something of it. And part of one of the tasks he took on was to type in, I think, the 6502 implementation of Fig Fourth, which I think was probably written by
Bill Ragsdale.
Bill Ragsdale.
Hmm.
I think that's probably how I got introduced to it. So
Okay.
prior to that, though, I had created my own Fourth on the Ohio Scientific, but of course it was my own, so it was completely non-standard.
Hmm.
And at some point, I was interested in creating. I was basically just interested in high-level compilers,
Hmm.
and to me, Fourth was a high-level compiler,
Hmm.
um, as opposed to assemblers. I'd been working on assemblers for a long time, but I wanted something more powerful. And so I implemented my own compiler, I believe, in Fourth on the Ohio Scientific under my own Fourth. And then eventually I abandoned my own Fourth and started using the one that Bob Riling had typed in.
Okay.
Um, and I probably ported my compiler to it, but I don't remember. It's too long ago, I guess.
Okay. So in the early 80s, then you started to venture into some of the more commercial computers, the 8-bit lines of computers. The first fourth implementation of yours that I found was Color Fourth for the Radio Shack TRS-80 color computer. Um, by
I
It's from Talbot Microsystems. It's
right.
copyright you and somebody that is it Robert
Art
Talbot?
Art, yeah, I believe it's Robert Talbot. Yeah.
Okay.
He was, of course, the owner of Talbot, and he was in Southern California, and he was interested in selling it. So
Also,
he probably provided me with a 6809 listing, which I used.
okay. Okay.
But I don't think that was the first. I think I've seen some of the references you may have found as well,
Uh-huh.
and I think it did show that the Color Fourth was first, but I think it was the last of the series of 3 cartridges that I made. I
Hmm.
believe Vic Fourth was actually the first one.
Okay. Okay. So
Um,
so at some point then you decided to branch out from the Ohio Scientific and take a look at some of these other computers.
yes,
Okay.
the Commodore VIC 20 was, of course, very popular and very inexpensive in those days. It was a great little game computer.
Hmm.
And so I thought it was also 6502, which was very convenient since my other computer was a 6502. So I made a version of Figforth for the VIC-20,
Mm-hmm.
and I went ahead and implemented a bunch of additional features. I believe it had an assembler, but I think the assembler was only provided in listing form, so you had to type it in. But it had support for sprites and color and some limited forms of graphics,
Mm-hmm.
which you could do all on a TV, of course, which would have been connected to it.
Mm-hmm. Now
Um,
this was for human engineered software
yes,
who was big in the Commodore industry for
they were.
making cartridge based software. So
Yeah.
did was putting forth on a cartridge your idea on a ROM?
Well, no, I mean, I'm sure it was their idea. Um, there wouldn't, well, the only other way to get software onto the VIC-20 would have been through cassette, and that was not nearly as convenient as a cartridge.
Mm-hmm.
And so initially, I'm sure we decided to put it on a cartridge, and I'm sure they wanted it on a cartridge because it protected the software. They were trying to make money, and they didn't want people
Sure.
duplicating cassettes and stealing their software basically.
So
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 go ahead.
so the genesis of this, you had made a 6502 fourth for the VIC, and did you start shopping it around, and that's how you came in contact with human engineered software?
Um, it's my recollection that at the time well, I wouldn't, I, I'm not sure I would use the term shop it around,
Mm-hmm.
I believe I did contact them and find to see if they would be interested in distributing it.
Okay.
So
So then we can go out of order chronologically here. I think the next generation of this, then you made 64 fourth
yeah,
for the next generation of the VIC-20, the Commodore 64, also
right.
also by human engineered software. Did they ask you to do that, or was that something you came up with on your own?
I probably wanted to do it on my own. I at the time I believe I was working as a software engineer, and I wasn't hurting for money at the time
Mm-hmm.
particularly. So I think I it was just a more sophisticated computer, and I wanted to buy one and try and put a fourth on it. Uh,
Okay.
so yes, the Commodore 64 fourth turned out to be more popular because the 64 had a bigger, more characters on the screen. Instead of being 20
22.
20 characters across, it was 64 characters across on the
Yep.
screen.
Yep.
So, and I guess you could use probably a real monitor with it. All I don't remember if I did or not. I may have.
Okay.
And because of security at the time, people on the Commodore 64 were creating these things called cartridge rippers. So they would have RAM in them, and they would download a cartridge into the RAM and run it from there. And so there were security concerns about theft. So I ended up creating the only protected, pseudo protected software package that I ever did. I wrote I made modifications to 64 fourths so that it would not run out of RAM.
Mm-hmm.
And this is many years later, of course, but I did some search on the web, and I found there's still a site around somewhere that has patch information for how to work around my
Yeah.
protection.
Yeah. I think they attribute that patch to you. It's
Oh, really? Well, it's
yes.
possible.
Um, so so also in there at some point then there was the TRS-80 colored computer 6809 base fourth.
Right.
Um, and I think when we were talking before, when we exchanged emails before, you mentioned that it's possible that and I might be misremembering here, but you took a look at the 6809 FIG listing, and that was the only copyrighted FIG listing that you had seen.
Oh, I think you're right. And it may have been copyright Talbot Microsystems.
Oh, is that
I
right?
think maybe it was actually.
Okay.
Now that you mention it,
Okay.
so that could be why I worked with him because I needed to use his copyrighted listing.
Gotcha. Gotcha. So you made these fours for some three very popular, computers for the home market. And I noticed that in the literature, the fourth interest group, you had listings in there, or whomever was publishing this had listings for the fourth interest group for more information, contact these folks, that sort of thing. Was there a noticeable uptick? Did you do you have a feel for did this start to kind of motivate a generation of fourth developers?
Well, I wish I could say that, but I don't know that. I don't know really whether how much I influence things. And I'll always, I mean, in those particular days, I was working on fourth development and creating fourth systems by myself.
Hmm.
But later on, of course, all of my fourths are public domain, uh, not only because I wanted to use them, but so that everyone could use them uh, without having to worry about copyrights. So I I don't I do know that 64 fourth was sold several thousand cartridges.
Hmm.
I know they manufactured and sold quite a number, and when they went out of business, there were something like 1,000 cartridges that didn't get sold, and so they ended up being passed around uh, with some fourth vendor trying to sell them.
Hmm.
So,
I think they're kind of a rarity now. I think the Vic one is a particular rarity.
well, that wouldn't surprise me. I still have a 64 cartridge. I may have a Vic fourth cartridge here somewhere because I always wanted to keep a copy of them.
Sure.
Um, Actually, you were asking about something that affected the number of people in the fourth community,
Hmm.
and I think the fourth that probably did have a significant impact in the size of the fourth community was FPC.
Okay, that's a great
Uh,
segue because that's where I was going next.
it was based on Laxon and Perry fourth, um, but it was evolved rather dramatically from Laxon and Perry fourth. Laxon and Perry fourth was, I don't know if you remember, but all of the traditional fig fourths were um, similar to the fourth ink style of headers. That is, they had I think they were 3 character names and then a 1 byte count for how many characters were in the actual name. So if you were to do a listing of the vocabulary, you would not see the whole names. You would only see the first 3 characters of each name.
Hmm.
And I don't remember if Laxon and Perry had moved away from that or not, but I know for sure that I did because I wanted to see the whole name.
Yeah.
Um,
If you typed words on, at least on the MS-DOS version of, uh, it was, for me, it was Laxon Perry F83. And if you typed
right.
just the word words, you'd get a full list with very large words sometimes.
Oh, okay. Okay. So they had moved away from it,
Hmm.
which probably facilitated my doing it as well. If not, they
So
probably did all the work.
so before we get too far in FPC, so did I know that there was a fourth 79 standard. I don't know how closely you had adhered to it with those 8-bit fourths. And then there was an 83 standard. Were these good things in your opinion? Did they help to kind of define better fourths?
Oh, I think so. Uh, there was there was a desire to evolve forth into being more useful, and I think that the technological changes in terms of the internal design and in terms of the word sets went toward the goal of trying to make programs more portable. Now, that was always the has always been the complaint about fourth. This is when you've seen one fourth, you've seen one fourth.
Yep.
Uh, but I think 479 and 483 did go to help portability substantially. Maybe they were small steps, but
There were steps in the
it's
right
okay.
direction. So
Yeah,
I'm sorry,
steps in the right direction.
I had broken our momentum here. You were talking um, about basing FPC on Lax Perry 483.
Yes, and I don't remember the year of when F83 came out, but I think it was prior to the multiple fourths that I did leading up to FPC. You mentioned in the notes, let's see, Z fourth, T fourth, H fourth,
Oh yeah. Hmm.
and another one. I can't remember what it was. Though those fourths were primarily just kernels, meaning the standard set of, I don't know, 30 or 40 fourth words that you would have in a minimum fourth system. But they had different architectures in terms of the header structure and how the dictionary was built and vocabularies. And there was a time where I guess the word would be obsessed with performance. And I went to great lengths, ultimately in FPC, to make it able to compile very fast. Early fourths would have one single linear dictionary. And as you can imagine, if you have many, many words and you're searching through a linear dictionary, it takes time to find what
Hmm.
you're looking for.
Hmm.
So I went to a multi-threaded or a, multi-threaded dictionary in FPC, and those other fourths were steps along the way of just putting headers in different places and putting dictionaries in different places. Those were all, I believe, on the 8086. They were probably
Hmm.
all on the
Hmm.
PC.
Yep. Now, in addition to making it fast, you made it look like some of the contemporary compilers. Like it looked a lot like Microsoft's Quick Basic development environment. Was that intentional? I
Mm.
assume it was.
Well, along with experimenting with Forth, I was also experimenting with editors. So with Forth, I always, maybe not always, but most of the time, I had my own editor, which was included with the system. And I went through a period of time where I evolved the editor to make it more functional. And at some point, in a lot of cases, the editors, of course, included right in the fourth system. That's why these were not considered to be small fourths. These were large fourths. And when I say large, I mean a regular fourth kernel might be 40 or 50 kilobytes on a x86
Hmm.
processor. And the fourths I was making were hundreds of kilobytes. So you couldn't really make small applications with them. You, there was no way to strip out everything you wanted. So, which of course leads to something called TCOM.
Okay. Before we get into TCOM, was do you have any stories about the popularity of FPC? Did it make a splash in the MS-DOS world?
Well, of course, the MS-DOS world was enormous. So making it might have made a ripple, maybe perhaps.
Okay.
There were a lot of people that were interested in Forth that ended up using FPC for their own projects and for commercial projects. Now I can't list any of them, um, for one reason, it was all public domain, not their code, but my code.
Mm-hmm.
And so I know of at least one fellow that lives here in Texas that was working as a software engineer, ultimately as a software manager that used FPC for things at his company. Now, I don't remember what they were, but um, I used FPC for, well, actually, I don't remember if I used FPC for any work projects. I may have, I just don't remember.
Okay. Okay. So then in the progression here, you mentioned TCOM. Can you tell me a little bit about that?
Sure. TCOM, I mentioned earlier that when I had my own forth in the very beginning, I had created a compiler, and the goal of that compiler was to create a small application that only contained the code in it that was needed to run the application. So it was a way of stripping out all of the parts of forth, or the editor, stripping out the editor, stripping out everything that wasn't needed. And so at some point, quite a few years after that, in FPC, I created what I called TCOM, which was a target compiler, very simple. And I'm sure I started with the x86 architecture, since that's what mostly FPC ran. Well, that is what FPC ran on.
Mm-hmm.
And the goal was to create a version of Forth which could create applications that were very, very small. So the world's most popular, most useless application is called Hello World, and it's the first program anybody ever writes.
Mm-hmm.
And if I remember right, Hello World, written and compiled with TCOM, was something like 100 bytes. So it was very efficient. It had an architecture which was able to include optimizers for instruction sequences that it could detect within the code that was being generated by the compiler. So when you, let's see, I believe it used subroutine threaded code. So if you had a large function, the function would get called via a subroutine, and then there would be a return from subroutine at the end of the function.
Mm-hmm.
This made it possible to analyze the instructions being generated. For example, if you did a 4 space 3 space plus, as it was generating that code, it could look at the instructions that were being generated and go, oh, I know how to make this much smaller. And I don't remember if it could do the addition in at compile time and just compile the resulting number.
Mm-hmm.
But it was that sort of thing that it could do. It could look ahead and look behind, and thereby generate very efficient code. And so the optimizers were individually named and included as a part of the compile for a particular target processor. And so there ended up being quite a few target processors, most of which I did not write. They were written by other people who needed to be able to compile forth code for a particular target processor, for the application that they were trying to use. So let's see.
Now this was still all. This was not a commercial product, correct?
No, it was all public domain. What I did end up doing was writing something like 30 or more sample programs that could be compiled with TCOM for various kinds of simple activities. Like one of them, for example, would be serial communication. So there was an RS-232 application that I suspect would just echo characters that you would type on the keyboard,
Mm-hmm.
and anybody could open that up and go, well, I need to be able to use some of this functionality, and they would just take parts of it out and stick it in their code.
Mm-hmm.
So it was kind of like a source code library of various things. And in fact, there was even an editor called SZ, small z, fourth, or small z editor, which was set up to be able to provide a kind of a limited development environment for TCOM. TCOM had listing generators for each of the targets, so you could, and it would create printed listings or machine. Well, you didn't have to print them, of course; they would be created on the disk.
Mm-hmm.
But it would create listings so that you could see what the assembly language was that was being generated. And it ultimately included a not real time, sorry, included a debugger, interactive debugger, so that you could debug your code. And the debugger was knowledgeable of the listing file format, so that it would be able to single step or multi-step through the program, and you could watch what was happening, including looking at registers and things like that. So that was done for Samsung. The
Okay.
debugger, in fact, TCOM may have come into existence because of Samsung. I'm not sure. It could have. Bob Reiling, by the way, wrote was it Bob Reiling? Yes. Bob Reiling wrote a completely retargetable assembler for it, for FPC and for TCOM, which which enabled us to create targets just by changing the description file, obviously a very sophisticated description file
Mm-hmm.
of what the target processor needed to do to generate specific instructions.
This
So
this all sounds like a really great piece of software. Did they?
it
Uh,
it
uh,
was it was amazing. I mean, I was totally thrilled with what it can do. And it still exists today in source code form, and you can get it. And of course, it's all antiques by modern day standards, where everybody works in who knows what.
well, there's still people using chips or workalikes of some of these old chips. I'm just
True.
curious. This was never a commercial venture at all.
Well, Samsung used it as part of a commercial venture, but TCOM and the assembler were still kept in the public domain.
Okay.
The parts that were copyrighted by Samsung were the assembler for Samsung, the target definitions, and it was one. In fact, there were multiple ones. There was one for something called the Sam 8, which was a Super 8 that was made by Samsung. Uh,
Okay.
and they also had a line of 4-bit microcontrollers that were used for keyboard for creating keyboards for computers, and we wrote targets for the 50. There was the based on called the 56,000, I think. And so I ended up writing a nice optimized compiler for a 4-bit microcontroller, and that was very challenging, as you might imagine.
Mm-hmm.
But it worked fine, and you could debug it, and it was really those were really good years.
Very cool. Okay,
A lot of fun.
going a little ways the other direction, along came Windows. And at some point you decided to make at some point you were a either the creator or a strong participant in the creation of Win32 Fourth. Can you tell us a little bit about that?
Okay, well, let's back up just a little bit. The When Samsung at some point in time decided they weren't going to really make any money making microcontrollers, so they basically they laid off the entire. We had about there was like 5 or 6 of us, I think, that were doing development system software and hardware development,
Mhm.
and they just laid off the whole group. So at that time, I was out of work, and that was my first time ever getting laid off. So I was a little concerned about how I was going to provide for my family, and not being someone who saved any money at the time, anyway. Um, my brother Mark worked. He had his own company in Santa Cruz, and they worked on an application called Painter, and they did various kinds of um, computer graphics work. And he hired me as a, I guess, assembly programmer would be the correct term, because they had and I don't remember the name of it. There was a blue box that some graphics company made that ran super fast, and he wanted to run some of their software on that blue box, and so he hired me to do that. I think he may have paid me out of his own pocket. I don't know. It wouldn't surprise me. Uh, it was a partnership between him and his friend Tom Hedges, and so I did that for like 3 months, I think, uh, till I got essentially an offer from not Thermo Fisher, from Finnegan to come. I'm sorry. No, I've got the order wrong. The work with my brother was prior to Calma. I'm sorry,
Okay.
um, prior to Samsung. So then I went to work for Samsung
Mhm.
after working for my brother. So when Samsung ended, is that right? Probably isn't right.
This podcast's all
It
about
doesn't
straight
matter.
pointers.
Yeah. Anyway, so eventually I went to work for Finnegan, who made analytical instruments, and they had a data system that was written in Forth. And um, my friend, who was also a Forth software engineer, was hired by them after Jerry Bautel passed away, to come in and work on their application software, which was all based on a 16-bit Forth system of their own design, and was supporting a very large data acquisition and processing application. But it was so large that they ended up with creating something like 12, 12 overlays, program overlays, so they could get different parts of the program into memory where it would be executable.
Okay.
And I think this was done, I'm pretty sure it was done on x86. It was done on, not positive, but I'm pretty sure it was done on a IBM PC.
Okay.
And so when after my friend was hired, he hired me to come in and work with him on this. Um, we decided that we didn't want to work on a 16-bit Forth system. We wanted to work on a 32-bit Forth system, which today's, of course, is small compared to everything being 64 bits.
Sure.
And so over a weekend, he created a 32-bit Forth system for Windows NT. Now, I had all of my tools and development stuff from FPC. In fact, I remember a conversation which my boss at Finnegan was very impressed with. He said when I came in to interview, I told him that I brought all my own tools with me, and he thought that was pretty strange for a software engineer. But that's the way it worked for me anyway. Anyway, so my responsibility was essentially to expand the kernel written by, I sure wish I could remember his name, and build it into a fourth system that we could port the 16-bit application, enormous 16-bit application onto. And I did that. I'm not sure how long it took. We ended up hiring Bob Smith. Oh man, the guy with the early electric car. If I can only remember his name, maybe it'll come later. He'll be disappointed if he hears this and doesn't hear his name. But anyway, Bob Smith wrote the arithmetic packages for it, a floating point package. Oh gosh, let's see. We eventually we got, it probably took about, I don't know, maybe 3 months or something to get the fourth up to a point where we could start trying to port the app to it.
So really quick here, I just did a quick Google search, and the other names I see here are Andrew McEwen and
Andrew McEwen was the guy who wrote the kernel.
And Jim Schneider.
Jim Schneider wrote the assembler for FPC, I believe.
Okay.
And that was the only portion of FPC that was copyrighted. Jim didn't want it to be public domain. And I accepted that.
And there's another name here and another link, Robert Ackerman.
Well, the name's familiar, but I don't, he wasn't at
Finnegan. One of the core ones? Okay.
Yeah. Boy, I can see his face, but I can't tell you his name.
Okay.
Anyway, so when we ported the 16-bit fourth application onto Win32 fourth, we created Win32 fourth in public domain, left it in the public domain. But as we ported the application onto it, we realized that it was going to be much less, let's see, what's the word I'm looking for? Dangerous, much more reliable if we left it as its current architecture as 16 bits. So what we did, we actually did convert it to 32 bits, I think, but we took all the overlays that were there and we laid them in physical memory so they were all available at the same time. And because we weren't confident in the reliability of these enormous changes we made, and I do mean enormous, we added bounds checking on every memory access that the application did into an array or anywhere. Every time you did a memory access, we did bounds checking on it to make sure it was valid, which has rather a significant amount of execution overhead, as you might imagine. But at the time, we were much more concerned with reliability, and that enabled us to work out a lot of bugs, and it enabled us to make the application reliable after maybe 6 to 8 months, I think. We actually did ship that product out to the customers that ran on Windows NT. We had to, I'm not sure how much of the user interface we converted to standard Windows stuff. I don't think we did convert much of it to Windows. I think it was using the regular low-level graphics capability of the machine.
Okay. Okay. Was that
Okay.
was that one of your last force that you created?
Um, yes, I guess it was. The Now, of course, Finnegan became Thermo, and then it became Thermo Fisher over the years as I was working there. And the goal of this particular task with Win32 Fourth and this huge application was to be able to make modifications to it, additions to it, and have it still run reliably.
Mm-hmm.
So we were successful. In fact, we even did a second release of that application with additional features. And at at that time, we simply turned off all the memory bounce checking because it was reliable enough at that point. It didn't need to have it anymore, and advertised it as a huge speed up, and everybody was pleased by that, of course. Now, the reason now Finnegan, when Jerry Bautel passed away, apparently he had been brought in to finish up a bunch of work on this application that was started by a group of several different software engineers that I never met that all quit. And so he was brought in as a contractor to try to fix dig him out of a hole, as it were.
Mm-hmm.
And that ultimately he passed away. And so we were brought in to do essentially the same thing. Now, where was I going with that?
Well, my question was that the one of the last fourths that you had a hand in creating?
Oh, I see. Yes, and I backed up because I wanted to get the point in about the second release.
Mm-hmm.
But yes, it was. Oh, and the reason it was the last one was because we moved to Texas from Santa Clara. Myself and half a dozen other people and their wives. But I was the only software engineer that they moved. So once they moved us here, we were responsible for maintaining essentially the instrument control software, that big application. But they knew that they had to replace it, so they hired a large number of C programmers and set them loose to do that. And my recollection is that they fired them after they couldn't do it. And then they started again using C Sharp, which was the early days of C Sharp. And so we ended up writing the drivers or Andrew probably ended up writing the drivers for in C Sharp for this new data system that Finnegan was created. And so they had no interest in Forth. Finnegan had no interest in Forth. They just wanted the darn thing to work and
Sure.
produce the right results and the data. So they ended up with something like, I don't know, 30 software engineers supporting this new data system written in C Sharp
Mm-hmm.
that were located in Santa Clara. And we had maybe 3 or 4 software engineers in Austin who were doing the same thing, but with just with the drivers. And it ended up being very successful and was only replaced, or was in the process of being replaced in the early 2020s.
Wow.
So that was a long life for that software.
Sure.
pretty long anyway,
Sure.
from 2000 to 2020.
Sure. Do you think do you
So,
think do you think Forth has a place in today's computing world?
oh, I think it does. I'm you. Let's see. Take my glasses off for a second here. See if I can find something. Oh, here it is. I know that nobody can see this, but you.
Mm-hmm.
But this little tiny, what is it? Less than 1 inch square
Yep.
PC board with chips on it and a single USB-C connector is a computer. And if I get my magnifying glass out, I can probably even read it's called a Seed Studio ESP32C3.
Oh, sure. Mhm.
So this thing runs Forth. Uh, there is a Forth for it available on the internet, and so I ordered one of these little boards
Mhm.
and downloaded it and was able to get my computer to install it in the ROM or EEPROM or whatever is built into the card. So yeah, there's definitely a market for it, uh, for small hobbyists at the very least. And there's no reason you couldn't, you know, put these little tiny computers into large systems because they have Wi-Fi and Bluetooth and
Sure.
everything you need to talk to each other.
Sure. Tom, if you could send a message to budding Forth programmers, what would it be?
Well, I would say that the one thing Forth did for me more than anything else was it taught me how to think, for one thing. It taught me how important it is to make code reliable. In other words, Forth is a very easy language to screw up. If you're going to write a Forth program, you basically need to know what you're doing,
Mm-hmm.
and it doesn't protect you from really anything. And if you want to write reliable programs, you have to be very precise in what you do. So I'm sure part of that was just my personality, but for anybody interested in getting into Forth, it will teach you how to think, which
It's
while that may
handy.
seem odd, it's very useful,
Mm-hmm.
and it can be applied to all kinds of things later on in life.
Great. Well, Tom, this has been a pleasure.
Me too. I've enjoyed it.
All right. Take care. Thank you.
All right. Thank you.
Thank you, everyone, for listening. Let's do this again soon. Take care.